Hey guys, okay, so today we're going to do 1-9, proving that triangles are congruent. Okay, so let's start with the first example. They did is they gave me this rectangle and they want me to prove that AD is parallel to BC. So I'm going to look at my rules that I was given, right? And I have this little paper written down. You might want to do the same, okay? And if I look at parallel lines, these are parallel lines here, right? I notice that what exists inside are alternate interior angles. So I can use alternate interior angles to prove that these are parallel lines, okay? It's kind of like thinking backwards. So if I could prove that alternate interior angles exist in here, that would probably be my best strategy to prove this. Remember, for our purposes, if it says prove here, it means it's possible. Okay, so let's start with the given. The given, right, says that AD is congruent to BC and AB is congruent to DC. Okay, now I look at my rules, right, and I notice here for starters I have two triangles. If I can prove that they're congruent, I have a lot of power here, right? So I'm going to try to prove that these triangles are congruent, and I can say whatever I want about any type of angles that exist within these two triangles from that point. So here I look at my rules, right, and I have a shared side. So I'm going to use my shared side right here. All right, so now I'm going to just label my lines real quick before I move any further, and I'm going to say this is line 1, and that's given. I'm going to make this line 2, and that's given. Then I'm going to make this line 3, and that is a shared side. Now I could say that my triangles are congruent. My triangles are congruent because of side, side, side. Okay, so now what I suggested earlier is that inside of here, I want to prove that I have alternate interior angles. Right? What I'm going to do is I'm going to write this step up first. So I have my givens written down already. Right? I'm going to add the shared side. So I'm going to say DB is congruent to BD, and that is because they're shared side. Now, right, I could say triangle ABD is congruent to triangle CDB. I think that order is right. Okay, and we're going to say that occurs because of side, side, side. All right. Now, let's take a look at what we wanted to do. If we go back, right, when I said if I can prove that I have alternate interior angles inside these two this rectangle, right, I could prove that these are parallel. All right. For what it's worth, we actually don't know it's a rectangle. Okay, well, we do now. Opposite sides are congruent, but I also need to prove that the opposite sides are parallel. So, right, I'm going to see if I can find alternate interior angles inside here. Right, now alternate interior angles mean that there's a transversal between two lines, okay, and I have these angles here. Well, if I say the lines are going this way, right, we want to say, I could say that the lines are going this way. I could say that this angle and this angle are congruent. And the reason why I could say that is because these triangles are congruent. I could also say that this angle and this angle are congruent. And I could say that because the triangles are congruent. So I could say this is because triangle ABD is congruent to triangle CDB. I could say that here as well. Okay, I can make that line 6, so I can break that up. I could write them both on the same line if I want to, but I'm going to separate it. Okay, so it's a little bit easier for you guys to read. All right, so line 5, I'm going to say that angle ADB, right, is congruent to CBD, angle CBD. Okay, and that is because triangle ABD is congruent to triangle CDB. Okay, so next, right, BDC, angle BDC is congruent to ABD, congruent to ABD. And I'm going to say that too is because triangle ABD is congruent to triangle CDB. Okay, so now I proved that these angles exist. I can now state, right, that AD is parallel to BC, and I could state that because angle ADB is congruent to CBD, and there we go, BDC is congruent to ABD, and they are alternate interior angles. Alternate interior angles. Okay, let me make sure you guys could see that at the bottom. Perfect. Okay? All right. So that's how you do that, right? On your other proofs, it's going to be a similar situation where you're going to have to think backwards. All right, let's take a couple of quick examples here. Example number 4. Example number 4 actually uses the angle bisector rule. Okay, this, I think that's PX, is bisecting this ZXY, right? Okay, PX is bisecting that. So that means we're going to have two congruent parts here. Okay, and now our problem says, right, that the measure of angle 1 is 12x plus 3. So I'm going to write that in, 12x plus 3. Then it says the entire angle is 27x minus 3. This is half of this. Okay, this is half of this. So what I can do, okay, the easiest way to do this, I think I might have done it slightly different on another video. The easiest way for me to do this is to multiply this, the smaller guy, by 2, and solve. So that becomes 24x plus 6 equals 27x minus 3. All right. Now what I'm going to do is I'm going to just solve it. I'm going to subtract 24x. I am subtracting the entire term, so I can do that. And that crosses out. Then I'm going to add 3 to this side and this side. Okay? And then that cancels itself out there. That equals 0. So now 27 minus 24 is 3x, and that equals 3. So I divide by 3, and x equals 1. Okay, next. Give you guys a second to look at that. Okay. All right, last one. This one actually doesn't use any of the rules, but what it does tell you is that this angle is equal to 90 degrees. If this whole angle is equal to 90 degrees, right, This isn't necessarily bisecting. We don't know that. In fact, we do know it's not bisecting because that's 52 degrees. If this was bisecting a 90-degree angle, this would be 45, right? So I could add these two up to equal 90 degrees. 8 plus 3x plus 52 equals 90 degrees. All right, combine some like terms here. So that gives me 60 plus 3x equals 90 degrees, right? I'm going to subtract 60. Subtract 60. Let's see, how are we doing here? There we go. Subtract 60. I'm going to have 3x equals 30. Divide by 3. Divide by 3. And x equals 10. All right, I hope you guys found this video helpful.